For number one, they give us the cost. The telephone calls costing 40 cents or more by a household over a period of 3 months. And they give us all this raw data here. Now, it says state why it's advisable to admit the 1.66 for a stem. Well, you'll notice it's the only one. It's an outlier. And the next closest number is going to be 1.12. So we're leaving it out because it's an outlier, but more importantly, because the next largest stem is going to be 11. So that means that I'm going to write the stems 12 through 15 with no numbers or no leaves next to them, and that just looks kind of silly. So we're going to leave it out. Anyway, we're going to see the graph here. First thing we've got to do is we're going to draw our bar. I'm actually going to make two so I can set up my key here. And the key is going to be, in this case, I'm going to say 5 dashes. It means it's 56 cents. All right, now I've got my key. And I got my stems 4, 5, 6, 7, 8, 9, 10, and then 11. And see, all I've got to do now is go through and find the numbers that go along with each one of these stems. And it's really kind of just a tedious kind of process. You'll notice there's a lot of 40s. And so I would suggest that you go through and circle them, and then try to carefully pick out the lowest ones. You'll notice that we've got 40s here. Let's see, how many 40s are there? Looks like there's 3 40s. So that's going to be 3 zeros. So then as I go, I'm just going to cross them off. So I've got 0, 0, 0 for this first stem. And then I look for the next highest number, and it looks like it's going to be 42. And there looks like there is, no, I take it back, there's a 41, so that's the next one. There's only one of those. Now there's a 42, and there are 3 42s, so that means I'm going to put 3 2s here, and then I'm going to finish the rest here for you pretty quickly, because you get the idea. Basically all I'm doing is finding the numbers and putting them on my stem and leaf diagram. When I'm done, I'm going to end up with something that looks kind of like this. Now, they also mentioned that they want us to put high for this 1.66, the number we left off. And so typically that kind of thing is written next to the key. And we would just put high 1.66, meaning that there is a value that is in the data, but that we didn't actually include it in this diagram. Now, for part C, it says that we have to obtain the median and the mean. Explain your showing your work. Okay, so let's take a look at this. All right, so first let's try figuring out the median. And what we need to do is that I'm going to do it. I don't remember what I told you to do in class, so I'm going to do it with the 166 and then without the 166. So in this case, I can figure out the number of pieces. I'm using actual data, so I'm going to add 1 and divide by 2. And you'll see that I find out that the median is either 0.52 or 0.51, depending on whether I use the 166 or not. And then if I'm going to do the mean, well, they gave us what the sum of all the x's is. That includes the 1.66. So I'm going to give it to you with both, with or without. I don't remember, again, which I told you to do in class. In this case, it's kind of an interesting thing to see how the outlier is going to affect the median. You'll notice it affects the median a little bit. It affects the mean by a pretty good amount, by 4 cents. Now mode, well, we've got 40 cents happen 3 times, and 42 cents happen 3 times, and also 49 happened 3 times. There is no effect on the mode by the outlier. Okay, so let's look at the next one. And number 2, they give us the number of times each week that a factory machine breaks down over a 50 consecutive week period. Now this double use of weeks can be a little confusing, so let's make sure we're clear. We're looking at the number of breakdowns in a week over 50 weeks. So for part A, they want us to find the mean number of breakdowns for this period. And is it an exact value or an estimate? So what we're going to do is we're going to take the x's times their frequencies and divide by the sum of all the frequencies. And if I've got it written down, it's going to look something like this, and I'll find out that the average is going to be about 2.56. This is an exact value because the table can be rewritten as raw data. All I've got to do is multiply each number by its frequency. For part B, it says give the mode. Okay, well that's easy enough. The mode is going to be 2 because it happens the most often. And then the median number of breakdowns. The exact median, well, so because we can reproduce this raw data, 51 divided by 2, we're looking for the 25.5th piece of data. It's between the 25th and 26th piece. So that means it's going to be in this class here. Well, we know that it's got to be a 2, so the median is going to be 2. Let's take a look at the next one, number 3. For number 3, it says there's 5,000 schools in a certain country. The cumulative frequency table shown gives the number of pupils in a school and the corresponding number of schools. So they tell us outright that this is a cumulative frequency table, and by looking at it, it should be obvious that it's a cumulative frequency table because they keep on using this less than and equal to notation for the x's here. All right, so it says draw a cumulative frequency graph with a scale, and they give us the scale. And we're going to assume that our boxes, each box is a 1 centimeter block to follow the information that they want. So basically what we're talking about then is we're going to have a cumulative frequency and our 5,000 schools. Well, if each block is going to, 2 blocks is going to be 1,000, that means each block is going to be 500. And so we'll use that. And then we've got 600 pupils, and they want us to go every 2 blocks is 100, so that means every 1 block is going to be 50. All right, so that should be simple enough. Let's go ahead and lay out our scale. We've got our, it's a good idea to write down the points that we're going to be using in case anyone's curious about, what you used. And now that I've done that, I take the lower boundary for the first one, and then everything else is the upper boundary and the cumulative frequency. All I do now is set up my scale, make sure I label it, and I'm using the directions that they gave. And so once I've got it labeled well, now all I got to do is plot these points that I've set up. And so that looks something like this. And just kind of be a little bit careful. We're estimating here. I figure that roughly 5 spots, 5, each one of the increments in here is going to be 100. And so anyway, now I'm going to connect each one of these dots with a straight line, trying to be kind of careful as I go. And I end up with something like this. And now it says to estimate the median. Well, we've got 5,000 pieces of data. So that's going to be roughly 2,500. And if I go across and come down, it's going to be around here. Now, that seems like that would be about 270. What I want to show you how to do is how to do it algebraically. We're going to go to the number into the frequency over the frequency and compare that to the number into the class over the class width. So let's look at this. You see the class where we go from 200 to 250. We've used up 2,100. So that means the next class is going to go 400. And you can tell that 4,100 minus 2,100, that's 2,000. So we've gone 400 into the 2,000. That's the frequency of that class. Now we're comparing it to the amount we have to go into the boundary. That's going to be our x. And we can see our class width. Well, the class width of 250 to 350, that's going to be 100. So now all we've got to do is cross multiply and figure out what x is. Once we know what x is, we're going to add it to our lower boundary. So let's try it. If we multiply 400 times 100, well, that's going to give us 40,000, and then we have equal 2,000x. We find out that x is equal to 20. Now we have to go 20 into the class boundary, so 250 plus 20 is 270. And if you take a look at our graph, that's kind of like what it looks like. In B, it says find 80. It says 80% of the schools have n pupils. Estimate the amount of n. Well, if we multiply 5,000 times 0.8, we get 4,000. And then if I go ahead and try the same thing we did a minute ago, I'm going to end up with this. So let's take a closer look to see where these numbers came from. 1,900. Well, I'm looking for the 4,000th piece of data. And if I look before that, it's obviously going to be in this class 250 to 350, but I've already used up 2100. So 4000 minus 2100, that's where I get the 1900. I'm 1900 into this frequency, and this class frequency is 2000. Now I'm comparing it to how far I go into the boundary or the class width, and I don't know what that number is. I'm calling it X, but I can see the class width from 250 to 350 is 100. Now all I've got to do is cross multiply and figure out what X is. And then once I know what X is, I'm going to add that number to the lower boundary. When you solve for X, you find out that it's going to be 95. And that again, that's into this class. So if I take 95 plus 250, that gives me 345. And if I go over to my graph here and go down along 4000, you can see that it seems pretty reasonable that that's going to be 345. Now they also mentioned that we're supposed to round to the nearest 10, so our answer would be 340 for this one. There's a typo on this one for part C. I forget what number it was written down, or even what I told you, but I looked it up. It's supposed to be 250. If you didn't use 250, then don't change it. But if I am using 250, well, 201, well, that lines up pretty closely to 1600, and 250 lines up pretty closely to 2100. So all I got to do is subtract them. But in this case, I can just use the points and not worry much about the graph at all to figure this out. In part D, it says calculate an estimate of the mean number of pupils for school. So what we're going to do is I'm going to go ahead and write the frequencies in here, and then we should establish the mid-class values. And these are our boundaries. Now I'm going to go ahead and write this down because we're going to have the sum of the mid-class values times the frequency divided by the sum of the frequencies. Full disclosure, I went and looked it up because this is a test question, and they ended up using 50.5 and 125.5 and 175.5 instead of the numbers that I've got written down here. And I think the reasoning is because this is discrete data, but quite honestly, I can't find a logical reason for why it's the 0.5. So I'm going to look that up or work on figuring that out. So at this case, I'm happy with this answer if this is what you got. Number 4 is that the price of a CD is denoted by $X, and we have 60 CDs bought from different stores. And then we see this notation, this coded value here, which means that we've taken 12 away from each one of the prices. So we've got an N of 60, and we know that the sum of all our X minus 12s is equal to 53.40. And what they want us to do is they want us to find the mean. All right, so the mean of coded data, if I take the sum of X minus 12 and divide it by the N and add back the 12 that I took away from each data piece, that's going to give me the actual mean. So all I got to do is plug this information in. I got 53.40, that's the sum of all our X minus 12s. Divide by 60 and add 12, that gives me a mean of 12.89. Now the second part, it says there's another 40 CDs, and they tell us the mean for that. What they want to do is they want to put them together and find the mean of both. So keep in mind, if we're finding the mean of two means, what we've got to do is take the sum of the x's for both and add them together and divide by the n's for both. So let's go ahead and take a look at this. We've got the sum of the x's over n is equal to the mean. If I fill in the information I know, I find out that the sum of all the x's is going to equal 465.6. If I go to the first part and I figure out what their sum of x's are, I can find out that we've got 60. We know the mean. We just figured that out. The sum of all the x's is going to be 773.4. These are our two sums of x's. We know the two sums of the n's. That's going to be 100. So all we've got to do is take these two and divide by 100, and we'll find out the mean of both, which is 12.39. Now let's take a look at the last one. In number 5, we've got the weights in grams of a bunch of stones, and they're rounded to the nearest gram. So we know that there's going to be gaps in the table because some rounding has taken place. and we take a look. They want us to calculate the value of x. Well, frequency density is what they're referring to. That's the height of the rectangle. And so if I find the class width, which is 10, and then plug it into this formula for frequency density, I find out that the frequency is 30, which means then x must be 15. Now I can plug that in for that last class, and now I've just got to find the frequency density, 15 divided by 20, which is the class width, and I get 0.75. Now in part B, they want us to estimate the mean. So what we're going to do is we're going to sum up all the mid-class values times their frequencies and divide by the sum of all the frequencies. So all we got to do is find the average of the boundaries to find our mid-class values, and then multiply all these numbers times x to get our frequencies, and we've got the information we need. And I would suggest that you always at least write this part out. I wouldn't show every calculation, but this shows that you understand the method. And we need a total number of pieces here. It's going to be 285. All I got to do now is plug it in the calculator, and I find out that the mean is 26.55. Now, to calculate the median, it's going to be an approximation. About halfway is about the 142nd.5th piece of data. We can see clearly it's in the 26 to 30 class, and we're going to use the proportions to figure this out. What we got to do is figure out how far we went into the frequency and divide by the class frequency, and then compare it to how far we go into the class boundary and divide that by the class width. So how far did we go into the frequency? Well, 142.5 minus 135 that we've used up already, that's going to be 7.5 into this frequency. And then 7.5 divided by 75, which is the class frequency. We don't know what we're going into the boundary. The class width is going to be 5 in this case. So all I do now is cross multiply, and I figure out that x is going to equal 0.5. Now remember, that's how far I go into the boundary. My lower boundary for this class is 25.5, so that means the median is about 30. All right, I hope that helped. Thanks for watching.